Hey guys.
Hey, hi guys.
Yeah. Okay. So welcome to the live stream, everyone. So we'll be taking you through some of the new things that we've been developing in BIOS. We are headed to an exciting future, and I can't wait to share it all with you. So let's just get started. So over the past month, we've been working on several features. So you might remember that BIOS was how do I say? Like we made a lot of API calls and all of that, but we are in a stage where we can now host our own models. So that's what we've been up to, and I'll just quickly share with you some of the new advancements. Just give me a minute. Yeah. Okay, step one, uh, for starters, BIOS right now has tools, so you can just use at and you can see all the tools. We have AlphaFold integration, we have segmentation, we have a end-to-end pipeline to generate like binders within BIOS. So just to give you a perspective on how this segment thing works, I type at, click on segment anything, go to upload, and I can upload an image. So once I upload this image, let's say you're a biologist and you want a count of something. So I can just click, I want to count all of this within the sample. I just say count these and off it goes. So it's gonna access a GPU in the cloud. It's gonna run a segmentation model, and the result will be something like this. As you can see, all the samples segmented. So yeah, that's sort of the overview on how segmentation works. So another cool feature we've been adding, another cool tool that we've been adding is how to generate binders within BIOS. So what this will enable you to do is, like, I'll just quickly show you how it works. Yeah. So I go to target define. Let's say I want to generate binders for GLPR1 receptor. So I just click go, and it again uses a multi-step process to first identify, obviously find information about GLP1R. And if you actually zoom in, you can see that we can get annotation in real time. Like as I move across this, we can look at the hotspots. So there are 5 hotspots. We get a live view, and one of the interesting parts is we have a model called P2 rank on board as well. I think the biologists will have an understanding of what that is. And we also have 5 binding sites. And if I just click on generate binders, we have 3 models right now. PX Design D, which is from ByteDance. We have BoltzGen, and we obviously have RF Diffusion 3 as well. So what these do essentially is they generate they do binder design in real time. So what you can see is all these candidates over here. So I'll just check in. Let me see if everything is good. Okay, cool. Good. So what we essentially get is all these binders, and if I click on this, I'm going to get this binder design, and I can get the sequence as well. So this is protein x design, Boltzgen giving us candidates for GLPR1. So what we can essentially do is we can send this off to a wet lab and get it synthesized. So these are potential candidates that we can send off to a wet lab and get synthesized. So that's just a quick rundown on some of the new things that has been happening in BIOS. And I think I'll hand it over to Ritvik. He can show you some tiny new features that we've added as well. Ritvik, please take it away.
Yeah, sure. So we have been working on adding like new tools um, to the fast chat mode. Um, when I like once I get my thing running, like Jeev, maybe like honest, maybe like you can like talk a bit about like this new protein binder thing. Like I'd like to know more about. Like maybe the audience wants to know more about it. So I'm just getting like my system ready. G.
Yeah, maybe Gautam, could you share your screen and show some of the new additions with regards to BIOS?
Yeah, let me share the screen. Yeah, can you guys see the screen?
Yes, all good. Yeah.
Yeah, so I was mainly, working for some of the backend optimizations for the fast chat mode. And so for example, so basically, we did already had a, 5 step very rigid pipeline, but now we do have a basically autonomous, agent deciding based on the queries where your query needs a tool call or not, right? So that's one optimization. So we have completely changed the chat mode. And also I've done few optimizations, like if you can see the screen, for example, if I am doing this query, right, we do have a thinking indicator here, and we do have the streaming, right? So basically that's very good for uh, basically for the speed as well, right? So yeah, mostly I've been working upon on the chat mode, like basically optimizing the streaming, and doing the optimization which can basically help us get the outputs faster. So, and yeah, a couple of bugs also I was like basically solving for the chat mode. So now we do have the streaming as well for the users, and it can be of really help for the people. Yeah, so
Great. So is my audio better right now? Can you
yeah, yeah, it's good.
maybe
Yeah,
give a thumbs up? Yeah. So let's. So we showed you like a fast overview. So let's just get in depth on certain things. So I'll just share a specific tab and show you like what's the whole hypothesis behind this, right? So what you see on my screen right now is the plan, like what BIOS can do. So essentially, let's take the example of GLPR1. So GLPR1 is a receptor, and we essentially need to, we are enabling BIOS to design binders. So biologists can now design a binder for GLP-1 receptor within BIOS. So what we support is all the models that are required to do this. And just to quickly go through that, so from this list, we currently have PX Design Incorporated, we have Bolts Gen, and we have RF Fusion 3. We're gonna extend support for more, but we found out that these three were the state of the art right now, which is why we support that. Just to give you a hindsight of what you can do within BIOS, it's a 9 step process. So you initially start with your target definition. So let's say GLP-1R. Data is retrieved from UniProt and AlphaFold, and it's annotated like I had shown you, and the step number 4 is the binder generation using these three models: Boltzgen, Protein X Design, and RF Fusion 3. And step number 5 is scoring and identifying. So what essentially happens in step number 4 is you get like 5,000 candidates, but all these 5,000 candidates won't be a proper fit for the receptor. So things can, once the receptor and binders come together, the binder can fall apart. A lot of factors come into play, but scoring enables us to again filter through uh, various like reduce the number from 5,000 to less, and we have molecular dynamics and more techniques that we'll use to filter it further down. And then we get like top 10 to 15 candidates after all 6 steps, which we can send out to adaptive or other labs essentially. But something we would like to announce is what we are planning to work on is we will be building an in-house robot, and it sort of look like this. So what it would enable us is uh, have our own wet lab where we can send things to the robot, and it can handle a pipette, it can transfer things into a well plate, pretty much having everything within our ecosystem end to end. So that's the goal. And step number 9 is something which most AI scientists do not have, that we plan to incorporate, is a feedback loop. So what happens is, even though we have 15 candidates, all of them are not good enough. uh, Things can, again, even the best top two can still not be good. So we take the learnings, find the best ones from the 15 candidates. We again give feedback to our step number 4, which is the binder generation, so that now we know what works sort of well and how can we improve it in the second one. So this feedback loop is super essential. We've been talking to one of our in-house biologists, Rafa, who's helped out a lot on this end. And yeah, so that's just an overarching goal where we'll be able to do foundational research within BIOS. So I'd like to know if you want to share more on this, maybe give them a perspective, BIOS and where it's headed with regards to this.
Steve, did you call me out or I was not
Yes,
sure?
yes, yes, yes.
Yeah, so I had the pleasure to visit Chief in Bangalore and could see firsthand what a robotics lab looks like. Basically, a bunch of tools, a bunch of machines working, 3D printers printing. It was a quite exciting experience. And I think we're at a point right now where inflection point where the AI tools get so good, and if you combine them with the robots, that they have like a real understanding of the physical world. And this obviously has a lot of implications and opportunities for doing automating lab work. We had also a friend there, biologist Caitlin Lewis, and she did bench work in the lab, and she told us how many Saturdays she spent actually pipetting things. And yeah, so this idea aroused, okay, how much can we automate? How much of the feedback can we feed back into the model and the system? And so we have definitely some ideas. I think the way that will get us there is working closely with biologists and learning from the experiments. And the first step, obviously, is to make BIOS, to enable BIOS to new tools and enabling the software, and then start building a robot around this and closing the feedback loop, basically. The ultimate goal is obviously to have much more shots on goal to automate the 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 first step of the pipeline, and then creating more medicines and bringing those to people as a result. But yeah, the more that can be automated, the more you free up time again for other tasks, higher value tasks, and yeah, basically sitting back in the driver's seat and observing what the system does would be the ultimate goal. And step after step, we're working towards this. And the protein binding tools and new tools in BIOS are just a mosaic in a much bigger plan. Yeah. Chief, do you want to comment on that?
Yeah. So just to give you a hindsight, right? Like Johannes was telling. So my previous history is in building, I mean, in robotics. So I'll just quickly share you. It's a robotic arm that sort of can play like table tennis. So if I just play it, right? Just give me a minute. Go back and share it again. Uh, yeah.
Match
Just give
time.
me a minute. Yeah. So if you look at it, it's sort of like an arm that is. It's something that can play table tennis. But the whole philosophy is that if something can play table tennis, it can be repurposed for handling pipettes. It's essentially a instead of the paddle, there'll be the arm, dexterous arm. So this is the robot that I built in my lab, and we will essentially be, how do I say, extending it to serve our in-house purpose, which is like wet lab experiments. So our whole thesis is that a lot of research will be taken over by agents, and even the final loop, right, the missing piece of the loop is the wet lab itself, even that will be taken over by robotics. So BIOS is uniquely positioned to have the entire loop in house. So that's sort of the whole purpose. So I'll just quickly show you the protein thing again before we jump on to our next announcement, which is we have a BIOS CLI. So that's super cool too. But let me just quickly share the whole thought process, right? Like, okay, we can take a receptor, we can identify binding sites. We have P2 rank, which is a model. We can generate binders. We have three kinds of models. We have Boltzgen, which gives us candidates, and we can then send it off to adaptive, or we can just use our in-house robots to essentially synthesize this uh, binders. So that's all about BIOS. Now let's go into the next exciting product, which is BIOS CLI. So how do you? The reason we even thought about BIOS CLI is because, like I mentioned, right, we are going into a future where research will be taken over by agents. So, in support of that vision, we are building a CLI that enables agents to interface with and use all the features that BIOS has. So, how do you start the BIOS CLI? You just type BIOS and you get this familiar UI that you guys are all used to. And I can just so one of the exciting features that we've been including in BIOS CLI is the ability to fine tune models. So right now we support um, like certain instruction tuned molecular instructions data sets and certain language models, but we will eventually extend it to even protein related models like ASM fold, which you can fine tune. So I'll just show you an example of how do you fine tune a language model for biotasks within the BIOS CLI. So I just say, can I fine tune QN4B on mol instructions dataset? So I type this. What it does is it starts a fine tuning job. It picks the instruct model and it picks the dataset. So this is an existing dataset on Hugging Face. But if users want to use their own dataset, they can do it as well. So I just press enter and it asks for which repo should it push the model to once it is trained. So it goes into my own Hugging Face account and it starts loading the dataset which is already existing on Hugging Face. And you're going to see that training. So it's asking, should I proceed with training? Yes, and the training job will start right away. So it even gives me a cost estimate which is around 78 cents. So pretty good thing. And the whole perspective, like I was telling, right, we are focusing on three main areas: foundation models, robotics, and wet lab. So, and these three complement each other, and BIOS is heading to a future where we can do all of this in house. And yeah, I'm super excited
Yeah.
to share it with you all soon.
Yeah. Maybe Chief, you want to dig a bit more into the CLI or
Yeah,
yeah,
sure.
in case.
Yeah, so let's have a more look into the CLI. What are its capabilities and more? So the training job has started, but let me open a new tab, and let's start again. So you type
And
BIOS.
we have
So
some
what?
comments. There's some music in the background, so maybe if it's possible, would be a bit better if it would be a bit more quiet, but probably should be
Yeah,
fine. I can hear you well. Yeah.
yeah, it's some background music the folks are playing. Sorry about that, but yeah, I'll just quickly just share what this can do. So I can just ask it a question, right? What can you do? So it asks me to run help. So these are all the features. So within BIOS, we have fastest deep research, we have the smart mode, autonomous mode, research papers, branch fine tuning. So pretty much all the features in BIOS plus the additional ability to, like, I can tell it to go to GitHub, clone ESM fold, and then fine tune it. So this is what the CLI essentially opens. This is the possibility. So I can just ask it open-ended questions as well. What is GLP-1? So now it actually starts streaming within the CLI. So we have streaming supported in BIOS CLI, and this is using the BIOS harness. So the possibilities are limitless, and yeah, we're super excited to give you guys access to this all. We'll be probably rolling out a private beta and get some feedback and
Yeah.
officially have
Yeah,
it
in
out.
case, exactly, maybe we should announce a private beta, and if someone is interested, please reach out to Ada or any other channel, maybe also Twitter, Bio AI Devs, and yeah, help us develop the product and make it better. That would be probably a good idea.
Awesome. So, is there any questions that anyone has? We can probably answer it. And if any of you guys want to show stuff, feel free to ask. In the meanwhile, I'll just keep the protein stuff open so that people who have missed out can see it and also the CLI. Yeah. Uh, is there anything more? I think we're good to go.
If not, I think we can also close it in a few minutes. But anyways, this is just so probably, yeah, stay tuned for Decide Berlin. This in the end of June. This is where we will probably release a polished version. We're just also, yeah, getting grooving us into product work, and yeah, so but in 1 month should be more released. And open source, that's a
Awesome.
good point. Yeah, you want to pick up, Chief?
So open source specifically what? Like the CLI? Could you say that again, Johannes?
There was a comment, do something in open source, which is actually a good idea.
Definitely. I mean, we're all in. Uh, that is the way forward, and yeah, even the robots. Uh, it's going to be exciting. I think. Yeah, we would love to get community's feedback as well. So we'll take that into consideration. But yeah, in general, just to summarize, we have the ability to generate binders. We have in-house robotics that has been kickstarted. We have a lot of fine-tuning capabilities to fine-tune models, all within BIOS. So, yeah, that's a quick rundown on things that we've been up
Yeah.
Yeah, super exciting stuff. And yeah, if anyone has any questions, about like on the platform level or about the chat mode, just feel free to ask as well.
All right, then I would say let's close it here. This is just a quick announcement, and stay tuned. The BIOS is actively improved from. It will, yeah, basically it will change a lot. We have a new vision for this product. We're taking in feedback. It's co-developed with biologists, and yeah, stay tuned for more. And thanks for listening and supporting.
Thank you, guys.
Thank you guys. So.